So as promised, in this video, we're taking a look at some vertical transformations of cotangent. So first of all, I just want to observe that all the changes I'm making to the trig function occur after I've evaluated the cotangent. So that is going to affect things vertically. And vertical transformations of tangent and cotangent can be a little bit tricky to spot. So if I take a look, multiplying by -2 is going to do two things. Now the negative sign is going to be very important. That's going to flip things over, and that's easy to spot visually. Multiplying by 2 is going to stretch things vertically by a factor of 2. It's already infinitely tall, so it's not going to be all that visually apparent. But what's going to help me to see that is plotting these points that are halfway in between my quadrantal angles, or the points that correspond to them, because that way that's just going to show that this point, well, I'm going to flip it, so it's going to come down, but then it's going to come down to -2. So those intermediate points will sort of show us the vertical stuff. Then this 3, notice we're actually adding the 3 because the negative sign goes in front of the 2. So this is the same thing as -2 cotangent of x plus 3. We're adding the 3. We usually write the constant that's by itself at the beginning just so it doesn't look like we're adding 3 to the x. So it doesn't look like we're changing the argument of the trig function. Okay. Moving this up 3, it's not going to be super visually apparent. So vertical transformations are much more visually stunning, or whatever the word is, for sines and cosines. But we can still do them for these things. So if I wanted to graph this, actually, what I'm going to suggest is that you pause the video, try this, then turn the video back on and see how you did. Welcome back. Okay. So since we weren't changing things at all horizontally, I'm going to mark off the same angles, 0, pi over 4, pi over 2, 3 pi over 4, and pi, and I've still got the same asymptotes. And of course, if I want to draw 2 periods, then I'll just keep going. Pi was 4 pi over 4, so this will be 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4, and 8 pi over 4 is just 2 pi. Okay. So those are the x values that we have. And now what we're trying to do is take the y values that we get in our standard cotangent graph. We're multiplying by -2, which flips them and makes them twice as big, and then we're adding 3 to move things up. So I'm going to just do that one at a time with these y values. 1, if I multiply by -2, becomes -2. -2 plus 3 becomes 1. Well, that's exciting. This is still going to be a 1. Okay. 0, well, 0 times -2 is still 0. Plus 3 is going to bump it up to 3. So I can see that's establishing the pattern that now we're going to be increasing, whereas cotangent before a transformation would be decreasing. -1 times a -2 would become +2. Plus 3 is going to be 5. And then I can connect the dots, getting this nice curve. And tangent and cotangent don't have any extra wiggles in them. They're just sort of nice, smooth curves connecting those points. Same thing's going to happen here then. We're going to go from a value of 1 here to 3 here to 5 here, and then I can play connect the dots, and there's my second period of this graph. Excellent. Okay, so next one we'll look at, we'll have some vertical and some horizontal going on.